Welcome. I'm going to talk about scalar and vectors now. Scalar and vectors. Scalar and vectors, possibly one of the most confusing topic in physics. Now let's see why this might be confusing. It's easier to start with some examples of scalar and some examples of vector. I'm going to start by saying that vector is something with direction, with a magnitude and direction. Whereas scalar has no direction. Scalar is just a number. Okay, not just a number. It is represented by a number, and we would be talking in both cases. We would be talking about physical quantities. So let's look at some examples. Scalar could be, okay, let me write down something like mass. Okay, mass, time, distance, speed, energy, temperature. We're going to see lots more of these in physics. Now vector, let's look at some examples. A vector could be, say, displacement, could be velocity, acceleration, force. There can be a few other things, but we'll be mostly looking at these in physics. Now you might notice that you might notice speed and velocity here, and you might wonder what's the difference between them. That's exactly where it can start getting confusing in physics. So let me start with maybe mass. All right, let me start with mass. So just think of a mass like 20 grams. Let's say I have a small piece of wood and it has a mass of 20 grams. Now if I think about mass, I think about it as a certain amount, a certain number of grams, and gram is my unit, and 20 is my number, and that's it. That's all there is to it, and I don't have to. There is no direction. Right? Mass has no direction. You can't say whether this piece of wood is up, down, left, or right. So it's just a number with a unit. So that's what mass is. It's a scalar. Now time, right? I can talk about time, like say 2 seconds or 3 hours. So that's time, right? Again, a number with a unit, doesn't have a direction. Distance maybe 5 meters. If I walked for 5 meters, that's my distance. And I might walk in a certain direction, but I'm not interested in that right now. I'm just interested in how far I walked, and that's the distance. So I don't worry about the direction. Now speed, okay, I might have walked at a speed of say 0.5 meters per second, really slowly, 0.5 meters per second. Again, I might have walked in certain direction, like to the east or west, but when I talk about speed, I don't worry about that. I just talk about how many meters per second I've walked, or how many meters per hour. So and so on, right? I shan't go into energy and temperature for now. That'll be for later. So we have seen some examples of scalar. Obviously, there's nothing about direction here. These are just numbers with units. Now let's look at a vector. I'll start with, actually I start with velocity. Now let's say I talk about velocity. I walk with a certain velocity of 0.5 meters per second. Okay. Now when I talk about velocity, I must also mention the direction. So for example, I'm actually walking towards the east. So I have a direction here. I'm walking towards the east at this speed. Okay, so if I talk about velocity, I have to mention both its magnitude, which is what this number is, and I have to mention its direction. So as I said earlier, magnitude and direction. Okay, so in other words, in physics, the word velocity has a rather specific meaning. Okay, and unlike the way we use the word in everyday English, where when we talk about velocity, we don't have to think about the direction. We would, in fact, always use the word velocity and the word speed as if they're the same thing. All right, you would just use whichever you like, just to have some variety, perhaps. But it's different in physics. It's different. Speed and velocity are completely different objects in physics. Okay, not completely different. The magnitude of velocity is actually speed. Okay, but they are different in the sense that the quantity that we call velocity, it has to contain two pieces of information: the speed and the direction. Right, so this is very important. Now I have to emphasize this very, very strongly, because a very common mistake is simply to think of velocity as speed in physics. The moment you do that, you're bound to make mistakes. So more on that later. Now displacement is closely related to distance, in the same way that velocity is related to speed. So in fact, the magnitude of this quantity, which we call displacement, is the distance. So for example, I might say walk for a certain distance of 5 meters. So that could be my displacement. But if I talk about displacement, I must talk about the direction that I walked in. So let's say I walked for 5 meters towards the north, to the north. So that would be my direction. So if I want to tell people what my displacement is, I must remember to say both the distance that I walked and the direction I walked in. So displacement must contain these two pieces of information. So the meaning of displacement is very strictly defined in physics. It has to have the two displacement. So unlike distance, which only has one information, which is just this number of meters or centimeters or kilometers. Okay. Now acceleration and force, we will look at these in the later topics about these quantities, so I shan't go into those.